Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Fadina binti Duraiman and my partner is Nurabila Shafika from Group A AS2515D2. So my title of experimentary is Characterization of PV module. Next is the aim. The aim is to investigate the electrical characteristic of PV module. And the objective, we have 4 objectives. The first one is to determine the IV curve characteristic of PV module. Second is to determine the PV curve characteristic of a PV module. Third is to determine the fill factor of the PV module. And fourth is to determine the conversion of efficiency. Next, we go to the procedure. So this is how the circuit is set up. What material we use is pyranometer. This is pyranometer, voltmeter, clamp meter, PV modules, temperature, wires, and variable resistor. So this red wire will be connected to the voltmeter and also the black wire. It connected here, and there will be another wire connected to the variable resistor, and the pyranometer will be hang here to detect the solar irradiance. So in table 3.2, the data is measured and recorded of time, solar irradiance, and PV module temperature at the beginning of the experiment. Next, the VR of variable resistor is set to 0, and then the value of VR is increased, and the corresponding current and voltage reading is recorded. The current and voltage reading recorded by using this voltmeter. Next step is for the last reading of VR. The VR will be set to maximum, so we can calculate the VOC, and it had been recorded in the table of 3.3. So time, solar irradiance, and PV module temperature at the end of experiment will be measured and recorded in the table 3.4. So that's all from me. I give it to Nurabila Shafika.
For data and result, there is 3 tables that we need to obtain. Table 3.1 is datasheet at STC and site information. The module manufacturer is Astro Energy CHSM6612P, and the type is HV345W. The PMP for this PV module is 345WP. VOC is 46.37 volt. The VMP is 3.38 volt, and the ISE is 9.67 ampere. The time of day is evening, and the latitude is 3.0401 to the north, and the longitude is 101.2936 to the east. The name of location is Makmal Lapangan FSG, which is berhampiran College Anggrek. Next is table 3.2, which is measured data. The parameter needed is time, solar irradiance, and PV module temperature. At the beginning of the experiment, at time of 4 p.m., the solar irradiance is 250 and the PV module temperature is 43.2. At the end of the experiment, which is at 4:05 p.m., the solar irradiance is 257 and the PV module temperature is 43.6. The next is table 3.3, which is experimental data. This is the data obtained from the experiment. The lowest value for irradiance is 250 watt per meter square and the highest value is 260 watt per meter square. For voltage, 0 volt is the lowest value obtained and 42.50 volt is the highest value obtained from this experiment. 0 ampere is the lowest value and 2.70 ampere is the highest value obtained for this experiment current. Value recorded for power is 0 watt as the lowest value and 78.80 volt as the highest value. From this table, we also able to gain the VOC, which is 42.50 volt and the ISC value, which is 2.70 ampere. In order to obtain the field factor value, we use the formula P max over ISC multiplied by VOC. As the maximum power obtained is 78.80 watt, we take the value 2.28 from the current data and 34.56 volt from the voltage data from the table. Then we take the value 2.70 ampere as we gain the ISC value from the table and 42.50 as the VOC value from the table. To obtain the solar irradiance value, we have to search for value G and A first. So, to obtain the value of G, we have to add all the value of irradiance from the table and divide it by 20. And then we will gain the value of G of 253.75 watt per meter square. For the value area, we have to multiply 156 millimeter and 156 millimeter, and we will gain the value of 0.024 meter square. So to calculate the solar irradiance, we have to use the formula PMP over G multiplied by A. We will take the value 78.80 as it is the maximum power value obtained, and we take the value G, which is 253.75 and value A 0.024. Then we will calculate and we gain 12.94. As the experimental data is obtained, we can sketch the IV curve and PV curve. As both curves is sketched, IP max, VP max and P max is obtained. From this experiment, we are able to construct the IV curve and also the power curve. The purpose of both curves are to define the P max. A PV module is characterized based on the current voltage performance of a string of cells in the module. The current voltage performance is characterized using the PV and IV curve. Both curve is valid at a particular irradiance and cell temperature only. There are 5 points at both curve which used to characterize the electrical performance of the solar cell or known as PV module. The 5 points are PMP, which is maximum power, VOC, open circuit voltage, VMP, voltage at maximum power, ISC, short circuit current, and IMP, current at maximum power. Field factor are represented as a measure of the squareness of the IV curve. It can be calculated using the formula of field factor equal to P max over ISC multiplied by VOC. On the other hand, the conversion efficiency of the PV module can be determined using the formula of efficiency equal to PMP over G multiplied by A. There is some distraction occurs while conducting this experiment as we obtain lower value of irradiance. This is because there is no sunlight while conducting this experiment as it is a cloudy day on that day. We also have to measure the solar irradiance at exact time same angle for each data to avoid any error of the data obtained. Precaution steps is taking as we cannot run and have to walk slowly while in the site as we might trip and fall at the site. We also need to wear safety equipment such as gloves to avoid electrical shock and hard hat to avoid our head from directly not the PV modules. That's all from us. Thank you.